Just briefly, leading into what I'm going to show here is something that we all obviously know probably, but that is the depth of a square is dependent on how close you are to it. Now, if you look down if you're standing on a tile floor and you look down at your feet, you'll probably see something that looks a little bit deep, like this maybe. Let's see if I find a vanishing point here. Something that looks like this. See, the depth relative to its width is pretty deep. But if I go way back here in the distance and I draw a square back here, I think you probably will all realize that it's much shallower looking compared to its width. So the depth of a square from front to back depends on how close you are to it. See, we can have a square the same width, say, as it's in a little different scene now. Let's say put a horizon here. But we're far away from this one, so you see it looks a lot shallower than the other one because we're farther away. So what we know here then is that the depth of a square depends on how close you are to it. That means the station point. The station point gives me the depth of a square. So let's start then here with a horizon line. Get me a T-square here. Draw a horizon line, and I'm going to use just a crude heavy pencil for this. Horizon line, and then I'm going to draw line, I'm going to call this line AB, which will be the front line of a square. This is line AB. Now the two sides of the square, this is 1 point perspective, so I'm going to draw lines back to the vanishing point like this. Now what I need to have you know, in 1 point perspective, the vanishing point is the center of vision. In 1 point perspective, the vanishing point is the center of vision. That's not true in 2 point or 3 point perspective, but in 1 point perspective, the vanishing point is the center of vision. So now, the procedure for finding the depth of this square depends on how close I am. So if I do this, if I draw a distance line, that is a line from the vanishing point, center of vision, down like this. Now, remember, this line represents a line that's in the air coming out toward the viewer, but because we can't draw it in the air, we fold it down and draw it on the paper. So right here then is a point representing the eye of the viewer. This is the station point. If you imagine this, if we fold that line down, the picture plane turns up and it becomes a line like this. So the horizon line becomes the picture plane when we turn it like that. So now what we have is a station point. We have here a distance line. Now in order to find the depth of this square, what I need to do is draw a 45-degree angle from the station point up to the horizon. I'm using this old beat-up 45-degree triangle. It's an old veteran here. Drawing from the station point up to the horizon, this line right here is at 45 degrees. Now we know that the two sides of a 45-degree triangle are equal. We know that this side is equal to this one. The two sides of a 45-degree triangle are equal. What I've just located here is called a measuring point. Remember that definition that sounded so inane? A measuring point is a point on the horizon line the same distance from the vanishing point that the station point is from the vanishing point. So we can use this to measure. And here's what we do. With a square like this, I can use this side to measure this side by drawing a line to that measuring point. And I do it like this. When this touches the left receding side of that square, I can at that point make a horizontal line that gives me the back of the square. So here is a means of plotting a square depending on how close I am. See? If I move this line up closer here like this and make a 45-degree angle from that point, you can see that what I get will be a deeper square because I'm closer to it. Remember, the depth of a square depends on how close you are. So in this case, I'm much closer. So what happens here when I draw the line from B to this new measuring point, I get a deeper square because I'm up close, like this. Now the thing is also, as I said before, if you're far away, you would also get a shallower square. So let's do that. I know I'm beating this to death, but it's good to kind of embed it in one's memory. So let's then here make another station point and draw from here another 45-degree angle up to the horizon to get a more distant measuring point like this. So this line goes up to the horizon, gives me a third measuring point. This means I'm much farther away, so if I draw from B to that measuring point, what I get then is this. I get a much shallower looking. So it depends on how close I am. So the depth of a square is in a sense arbitrary. If I do this, if I come over here and I decide I'm going to draw a 1-point square here, and I have not yet determined a measuring point, I could just do this. I could make a horizontal line there and say that's a square. Now it's a square because I said it is, meaning that I saw that square from just the right distance to make it that depth. So here's what we say. When you first start to draw something, the depth of a square is somewhat arbitrary. It just depends on how close you are. The only problem arises is when there are other things in the image that also need to be measured. Now all of a sudden we need to find a measuring point and make use of that. So let me set up for drawing that. What I would like to show here is using a measuring point, and I'd like to also show how this kind of like how this works. This is a little bit difficult to explain, but the way this works is we're making use of a fact in perspective, and that fact is lines drawn from the station point parallel to a line in the plan view will go to the same vanishing point when drawn in perspective. Now I know that's complicated, but I might be able to make it a little bit easier to understand when you see the drawing here. So what I'm saying here then is that lines drawn from the station point, that is from the plotting of where the viewer is, lines drawn from the station point parallel to a line in the plan view will go to the same vanishing point when drawn in the perspective drawing. So right here then is the horizon line, and then I have here, let's say line AB again, AB, and I'm picking an arbitrary vanishing point. I have the two sides of the square going back to a vanishing point. Then I'm going to go ahead and pick an arbitrary view distance. Let's use a triangle for this. Finding the view distance. So once again, this is that distance line which is meant to come out into space toward our eye, which we can't do, so we fold it down and draw it on the paper. This then is the station point. Okay, my purpose then is to locate here a vanishing point, a measuring point, which is a vanishing point in a way, for 45-degree angle lines. So this measuring point is a vanishing point for 45-degree angle lines seen in perspective. Now that's a little hard to understand because if you look at that last drawing I drew, that was not a 45-degree angle line, but it's meant to represent one drawn in perspective. So what we know here, this is the vanishing point, center of vision. This is the distance line. This is the eye of the viewer, the station point. This is a 45-degree line here. So let's imagine this. This is what the viewer is seeing. He's seeing a square here, not a rectangle, but a square, drawing to the measuring point like this. Now I'm finding the depth of that by making here where that line crosses the left receding side of the square gives me the depth. So let's diagram what's going on here. If I take this, the width of this square and carry it up here, what I'm doing here is I'm drawing this square seen straight down from an aerial view. And we say it's right up against the picture plane. So what I have to do is measure this to make sure it's a square and turn it up vertically, here like this, and get the end of that, the top of that square in here. Now understand, we're seeing two things at once here. We're seeing a view looking straight down on the scene. Looking straight down on the scene, what we see here is what this is the square, and this is the viewer looking down on the top of the head of the viewer. This is his line of sight toward the picture plane. By the way, when we folded this distance line down, the picture plane turned up this way. So the horizon line is also the picture plane. So what we have here is across this square a 45-degree angle like that. So here's the rule. The rule in perspective. A line drawn from the station point parallel to a line in the plan view, this is a plan view, will go to the same vanishing point when drawn in perspective. So here it is right here going to the same vanishing point. So we're looking down on this. These two lines are parallel to each other, and they will go, when laid down flat, they will go to this vanishing point. What you need to understand here then is that this and this line here, what that is a 45-degree triangle laid down flat. So we're seeing it foreshortened. This side is equal to this one. You see here? Equal, equal. But when we draw it in perspective, it comes out foreshortened like that. So the rule, and even this is the kind of thing that I tell students, even if you don't understand it, it still works. You can do it, follow the steps. You could still find the depth of a square successfully, even though you may not understand this principle.